Alright, linear inequalities are very similar to linear equations, only that instead of having the equal sign, you're going to have those symbols, less than or equal to, greater than or equal to. Okay, linear inequalities do not have this equal sign. Okay, so let me give you a couple of examples just to show you how you graph them. So if we have y is less than 3x minus 4, this is already written in slope-intercept form, so I'm going to go ahead and graph it just as I would if this was an equation. My y-intercept is negative 4, so I'm going to come on the y-axis down to negative 4, and I'm going to put a point. My slope is 3, which is the same thing as 3 over 1, so I'm going to come up 1, 2, 3, and then go over 1 and put a point. Now here's where things are different. If you have a less than or you have a greater than sign, you're going to do a dotted line. Okay, and then you're going to put arrows at the end of the dotted line. If you have less than or equal to or greater than or equal to, you're going to put a solid line like you normally would. And here is the reason why. Because the solution to this inequality, there's not just one solution, there's a lot of solutions, but the solution's not going to ever be equal to whatever's on the line. When you're graphing a linear equation, the solution is only what is on the line. For linear inequalities, the solution's an area either up above or below the line, and it's not. Because it's a less than symbol, it's never going to be what is on this line. However, if it was less than or equal to, it could be all of this up above as well as what is on the line. So that's the difference. That's why we put the dotted line versus the solid line. So again, because it's a dotted line, let me go ahead and graph this. And I know that this is not straight, so all right, so here's what this looks like. And again, you can see, maybe I need to kind of go over where our points are. Alright, so here's the 2 points, and here's the line. It's a dotted line. Well, with an inequality, because it's not equal to this, it's either equal to above or below, we have to do some shading here. So now we've got to decide, are we going to shade up above or are we going to shade below the line? What I do is I like to pick a point. And 0, 0 is always a nice, easy point to pick. And what I mean by that is I'm going to plug in 0 for x, and I'm going to see what happens with 0 for y. I'm going to see if it works, okay? So if I have 0 is less than 3 times 0 minus 4, I'm going to test whether that is true or not. So 0 is less than 0 minus 4, because 3 times 0 is 0. And 0 minus 4 is negative 4. Is 0 less than negative 4? The answer is no. So this was the point we were trying. Since it didn't work, this isn't the side that we're shading. We're going to shade all of this other side right here. Okay. If we had tried that pointing and it did work, that would be the side that we shaded. Okay, so let me give you another example. All right, let's say we have y is greater than or equal to negative 2/3 x plus 4. So again, I'm going to go ahead and graph it. My y-intercept is 4, so I'm going to come up. I'm going to come up to the 4 and put a dot. 1, 2, 3, 4, put a dot. And the slope is negative 2/3. That means my rise is negative 2, and my run is 3. I'm going to put a dot. Okay. Because of the greater than or equal to part, that means I'm going to put a solid line here. So change it so I have a solid line. Arrow on the other end. Okay. So that means my solutions are either going to be up above here, it could also be on the line, or they're going to be down below, but could also be on the line. So I'm going to pick a point, and I'm going to pick the point, let's pick 3, what is this? 1, 2, 3, 4, 5. Let's pick 3, 5, just to check. Okay? So 3, 5 is the point we're going to check. So we've got 5 is greater than or equal to negative 2/3 of 3 plus 4. Well, negative 2/3 of 3 is negative 2 plus 4 is 2. Is 5 greater than or equal to 2? Yes. So because it is, and because that worked, we shade everything up above. So that means the solutions to this inequality here are all in this area right here, or they could also be on the line because of